All right, so we're going to figure out how scientists measure the speed of a bullet,
Yeah.
like a speeding bullet,
Yeah, it's pretty wild.
using just a block of wood and physics.
It is fascinating. We're diving into a classic physics experiment, the bullet and box experiment.
Correct.
And it's based on an interactive simulation model from Open Educational Resources / Open Source Physics at Singapore. So picture this.
Okay.
You've got a wooden block hanging from a string, just swinging back and forth.
Okay.
Then, bam, a bullet slams into it and gets embedded in the block.
Okay.
The block doesn't just jerk around a bit, it starts swinging upwards like a pendulum.
Huh. Interesting.
And the height of the swing tells us how fast that bullet was traveling.
Oh, okay. I'm hooked. But how does the height of the swing connect to the bullet's speed?
Yeah.
Because wouldn't a faster bullet obliterate the block?
That's where the magic of energy transformation comes in.
Okay.
So that bullet's zooming along full of kinetic energy, the energy of motion.
Yeah.
When it hits the block, that energy has to go somewhere.
So it transfers its energy to the block.
Exactly. The transferred energy makes the block swing upwards as the block swings higher and higher. It gains potential energy.
Okay.
You know, the energy of position.
Right.
It's like a roller coaster at the top of the hill. It's all potential energy. And as it goes down, that potential energy transforms into kinetic energy. So a faster bullet with more kinetic energy leads to a higher swing.
Okay. That makes sense.
Yeah.
The source material mentions something about the bullet sometimes passing through the block.
Yeah.
What happens to the swing? Then does it still work the same way?
So this is where the model gets interesting.
Okay.
When the bullet passes through the block, the height the block reaches is pretty much the same no matter how fast the bullet was going.
Oh, wow.
To understand this, we have to look at how the simulation is built.
Okay, let's unpack that.
Okay, so the simulation uses a fixed force between the bullet and the box, meaning it assumes the bullet pushes on the block with the same strength regardless of its speed.
So in reality, a faster bullet should probably hit with more force, right?
You are absolutely right. A fixed force isn't perfectly realistic,
Yeah.
but it helps the model focus on the main event, which is the transfer of energy.
Right.
And by doing that, it can still make predictions about whether the bullet will embed itself or pass through.
So it's like a trade-off.
Yeah.
They sacrifice a bit of realism to get a clearer picture of the physics.
Yeah.
That makes sense. Is there anything else interesting about how they're using this fixed force in the simulation?
They actually hard-coded a specific value in the simulation to represent the force.
Okay.
And get this, it's always 1350 no matter what.
Wait, so they literally typed in 1350 as the force.
Yeah.
It's like we're seeing how the sausage gets made.
Right.
Even complex scientific models rely on assumptions and shortcuts.
Exactly, and that's an important takeaway.
Yeah.
Simplifying things sometimes helps us understand complex phenomena better, even if it means sacrificing perfect accuracy.
Right.
It helps us focus on the core principles at play.
So we've got this model that helps us understand the energy transfer when a bullet hits a block. That's cool and all.
Yeah.
But why should you care?
Yeah.
Where does this fit into the real world?
Okay, so let's think about it this way. Okay, so think about forensic investigations. Like this exact concept helps investigators, understand crime scenes.
Oh, like those crime scene shows where they use the bullet's path to figure out where the shooter was standing and all that stuff.
Precisely imagine a bullet is found at a crime scene. Investigators can work backwards using the bullet's impact to estimate the speed.
Oh, wow.
Potentially linking it to a specific weapon.
Wow, that's incredible. So this experiment is a powerful tool.
It is.
For solving real mysteries.
Yeah, and the applications go even further. Things like safer cars.
Oh, okay.
That can absorb impact better, or creating new materials that are more resistant to damage.
Wow.
It all goes back to understanding how energy is transferred during a collision.
Okay, now it's all starting to click. We started with this experiment, explored the science behind it, and now we're seeing how these principles play out in the real world.
Yeah, it's like peeling back the layers of reality and seeing the physics underneath.
Yeah, exactly. And speaking of peeling back layers, the source mentions who originally created this simulation model.
Oh, yeah.
Professor Fuquan Huang.
Yeah.
I wonder what other simulations he's created. He must have a fascinating mind.
I know, it makes you wonder what other seemingly impossible things we can measure and understand using physics.
That's a perfect question to leave our listeners with.
Absolutely. It's a reminder that the universe is full of mysteries, but we have the tools to unravel them.
Yeah.
If we're curious enough, the bullet and box experiment is just one example. It's a starting point for exploring the broader world of physics.
So what did we learn today? We dove deep into this classic experiment, explored the fascinating energy transformations,
Right.
and even got a behind-the-scenes look at how the simulation works.
And most importantly, we saw how these principles have real-world implications. You can see them in crime scene investigations, car safety designs, and even new materials. It all connects back to that basic principle of energy transfer.
So the next time you see something that seems impossible, remember the bullet in the box.
Yeah.
Even a speeding bullet can be measured and understood with a little bit of physics.
And remember, you don't have to be a physicist to appreciate the beauty and power of these principles. Just keep observing the world around you. Notice how things move, how they interact.
Yeah.
There's physics at work everywhere.
Well said. I think we've covered a lot of ground today.
We have.
Yeah, it feels like we went from like 0 to physics whiz in like a few minutes.
Right, and you don't even need a lab coat to get this stuff.
Yeah.
The beauty of physics is that it's all around us.
It really is. Like even just watching a ball fly through the air or light bouncing off a window. You know, it's all physics.
It's like this hidden language
Yeah.
that explains how the world works.
Yeah, and sometimes like with this bullet experiment, it can be used to like understand things that seem almost impossible.
Right.
So like next time we come across something that seems inexplicable, we should channel our inner physicist.
Exactly. Remember the bullet in the box.
Yeah.
It's a reminder that even the most elusive things can be understood and measured
Right.
with the right tools and a little bit of curiosity.
Well said.
Yeah.
I think that's a perfect note to end on. We've explored this bullet and box experiment,
Yeah.
delved into the physics behind it,
Right.
and even connected it to real-world applications.
We've seen how a simple setup can unlock some pretty amazing insights.
Yeah.
And hopefully we've sparked some curiosity in you, the listener, to keep exploring
Yeah.
the world of physics.
Until next time, keep asking those questions.
Yeah,
Keep looking for those hidden connections.
absolutely.
And most importantly, keep diving deep.